Welcome students. Today we are going to learn the topic areas under the curve. Areas under the curve. So in the previous topic definite integration, we know that integral 0 to pi by 2 sin x dx. We know that integral sin x is equal to minus cos x, and we have to apply the limits 0 to pi by 2. That is minus of cos pi by 2 is 0, cos 0 is 1. So the area is 0 to pi by 2 sin x value is equal to 1. Then the actual meaning of 0 to pi by 2 sin x is the area occupied by the curve sin x between the limits 0 to pi by 2. That is, this is the graph of sin x. We know that 0 to pi by 2, this is 1 and this one is pi. Sin x at x is equal to 0 is 0, pi by 2 is 1 and at pi is equal to 0. So the graph of sin x is like this. 0 to pi by 2 sin x means the area occupied by the curve sin x between the limits 0 to pi by 2. 0 to pi by 2. This will be the area of the sin x. So the meaning of 0 to pi by 2 sin x is the area occupied by the curve sin x between the limits 0 to pi by 2. This is the definition. So there are different kinds of curves will be there. I will explain shortly. The first one, suppose one curve is given like this. Y is equal to f of x is a curve with respect to x axis. Maybe the curve is like this. This is the curve. Whatever might be the curve. And here is a point x is equal to a and here is a line x is equal to b. We have to find the area of this one of the curve y is equal to f of x between the limits a to b. So this area is just nothing but integral a to b f of x dx. Integral a to b f of x dx, because it is above x axis. Above x axis we have to consider positive. In the same way, suppose the curve is like this. This is the same value x is equal to a and this is same x is equal to b. We have to find the area. The curve lies below the x axis. So we have to write a negative sign. That is, the area of this one is integral a to b f of x dx, but we have to write minus because the answer will be negative. So when you write minus, minus of the negative value becomes positive. So with respect to x-axis, if a single curve is given, the area we have to know whether the curve is above x-axis or below the x-axis. If above the x-axis, we have to write the positive integration, definite integration, and if it is below x-axis, we have to write negative integration. Suppose if the curve lies at some point, that is, maybe the curve is like this. It is x is equal to a and this is some point x is equal to c and this will be some point x is equal to b. So we have to find the area of this one, the curve. You observe this one, from a to c the curve is above x-axis, from c to b the curve below the x-axis. Then what about the area? Integral a to c the curve above x-axis. So we have to write a to c positive and minus of c to b f of x dx. This will be the required total area. This will be the total area. Since the curve lies above x-axis a to c and below x-axis c to b, so we have to write minus. This will be the required area. So when the curve is with respect to x-axis, either above x-axis, below x-axis, or sometimes like this. Suppose if the curve lies with respect to y-axis, when x is equal to f of y is a curve is given, then what happens? X is equal to f of y. There is a curve. We know that any curve lies right side of y-axis, it is positive, left side of y-axis negative. Maybe the curve is like this. This is y is equal to a and this one is y is equal to b. We have to find the area of this curve. X is equal to f of y, this curve, and we have to find the area. Now the area becomes integral a to b f of y dy. F of y dy. Because it lies on the right side of the x-axis, we have to write positive. Suppose the curve is like this. Y is equal to a y is equal to b. Then what about the area of this curve? Integral a to b minus f of y dy. Minus f of y dy. Because it lies on the left side of y axis. Here the answer be negative. When you write negative, the total value becomes positive. Suppose the curve may be like this. Sum of the curve like this. So this is the point y is equal to a, and here y is equal to c, and here is y is equal to b. So we have to find the area of this curve. So the area is equal to a to c f of y dy. A to c lies right side and y axis, but c to b, the curve lies left side of y axis. So we have to write c to b f of y dy. So these are the 6 types. When a single curve is given, first we have to verify whether the curve with respect to x-axis or with respect to y-axis, depends on the graph of the given curve. And next, when 2 curves are given, how to find the area? When 2 curves are given, we have to observe which curve occupies more area than the other. That means, suppose when 2 curves are given, y is equal to f of x and y is equal to g of x. These are the 2 curves given. Suppose one curve is like this, let it be f of x, and other curve is like this, y is equal to g of x. These 2 curves intersect at some point a and another point b. Now we have to find the area in between the 2 curves. In between the 2 curves. How to find the area? You observe this one. The curve y is equal to f of x occupies this a total area. This is the total area occupied by the curve f of x. So that is integral a to b f of x. The total area. But we have to find the area of this part only. Now we subtract the area occupied by the curve g of x from here, this part, you will get the in between area. In between area. So this is the way to find the area in between 2 curves. Suppose the 2 curves like this. This is the curve f of x and this will be the curve g of x. Then what happens? These 2 curves intersect at some a and b and c. We have to find the area of this one and also this one. We observe this one, a to b, the curve f of x, this is f of x curve and this one is g of x curve. F of x curve occupies more area than g of x curve. So from a to b we have to find integral a to b f of x minus g of x dx plus, you see, from b to c the curve g of x like this, and this curve from b to c occupies more area than f of x. Now integral b to c g of x minus f of x dx. So this will be the way to find the area of when 2 curves are given. Sometimes the 2 curves may be like you see the different kind of the 2 curves. Suppose sometimes the curve will be like this, y is equal to f of x, and sometimes the curve will be like this. So you see this is the point C and here is a point A and this is point B. This is g of x graph. We have to find the total area. You observe the graph. It is different, quite different from the previous graphs. A to C, the area occupied by this curve only, f of x only. From C to B, the area occupied by g of x only. So there is no necessity to subtract one curve from the other, because one curve, the area of one curve does not depend on the area of the other curve. So integral a to b from a to c, the area occupied by the curve f of x only. After c, f of x goes like that, and f of x dx from c to b, the area occupied by the curve g of x dx. So this is the way to find when 2 curves are given. So whatever might be the curves that was given in the question, first you have to draw the graph. The graph is very, very important, and then you go for the finding the area by using definite integration. Okay. I will explain some basic problems. First, sin x, as I told earlier, sin x graph. What about the y is equal to sin x or f of x is equal to sin x in between minus pi to pi, the area occupied by the curve. So, first you draw the graph of sin x. We know that minus pi, this is minus pi by 2, 0, pi by 2 and pi. Here this is 1 and this one is minus 1. We know that sin of minus pi is 0, sin of minus pi by 2 minus 1, it is 0 and 1, 0. This will be the graph of sin x in between minus pi to pi. You see, from minus pi to 0, the graph is below x-axis, and 0 to pi the graph above x-axis. So, the area from minus pi to pi, sin x is equal to minus pi to pi, the area of the curve lies below the x-axis. So, we have to write negative minus of sin x dx plus 0 to pi, it is above x-axis. So, that is sin x dx. Okay. So, both the curves occupies the same area. So, you can find only one area and add the remaining. So, that is cos x between minus pi to 0, that is minus cos x 0 to pi, cos 0 1 minus of minus 1 minus of minus 1 minus 1. So, you observe this is 2 minus of minus 2, that is 2, total area 4. So, one of the important point we have to learn from this graph is the one of the arc, this is the one of the arc of the sin x graph will be like this. One arc of the curve sin x or either sin x or cos x occupies area of 2 square units from here to here. This is one arc of the curve sin x. This is one arc of the curve. This is one arc of the curve. These are the areas 2, 2, 2. So we have to remember either cos x also. Cos x graph also, you know that minus pi by 2, pi by 2, this is 0. Minus pi by 2, 0, 0, 1. This is graph will be like this. Cos x graph will be like this. So, this is one of the arc. This is also one of the arc. This is also one of the arc. Either sin x or cos x, the area occupied by the curves either sin x or cos x is 2 square units. You have to remember this point. Any one of the arc of either sin x or cos x occupied by the area with x-axis is 2 square units. Okay. Next, one more question. Next, one more question. This is also important one. Y is equal to sin x, y is equal to cos x. In between any two consecutive point of intersection. The area occupied by these two curves in between any two consecutive point of or successive point of intersections. I will draw the graphs. You see here, this is 0, pi by 2, pi by 2, pi and 3 pi by 2 and it is pi. I am taking here pi by 4, this is 2 pi by 4 and this one is 3 pi by 4, 4 pi by 4 and this one is 5 pi by 4, 6 pi by 4 and it is 7 pi by 4. You know the values. First you draw the graph of sin x, sin 0, 0, sin pi by 2. Here I am taking 1 and here is taking value minus 1. So it is 1 at pi by 2. It is 1 at pi 0 and 3 pi by 2 minus 1 pi 0. So the graph will be like this. So this is the graph of sin x. And what about the graph of cos x? At 0, this is cos 0, 1, cos pi by 2, 0, cos pi minus 1, cos 3 pi by 2, 0, cos pi again 1. So the graph of this one is like this. This is the graph. So you observe the graph. This is the graph of sin x and this one is the graph of cos x. We have to find the area of in between the two curves, between any two consecutive point of intersections. So this is the one point of intersection of the curve. What is the point of intersection of sin x and cos x in between 0 to pi by 2? Exactly at pi by 4. So again, one more point of intersection occurs at 5 pi by 4. This is the point of intersection. So we have to find the area of this one. We have to find the area of this. In between sin x and cos x, any two consecutive or successive point of intersection, we have to find the area of this one. From pi by 4 to 5 by 4. Above the curve, what is the above curve or upper curve? Above curve means upper curve. That means which occupies more area. Sin x is upper curve than cos x in between pi by 4 to 5 pi by 4. So the required area. So the required area is equal to integral pi by 4 to 5 pi by 4. Sin x occupies more area. So sin x is upper curve. So we have to subtract sin x minus cos x. That is sin x minus cos x dx. Now you can apply integration. What about integral sin x? That is minus cos x. Minus cos x. Minus cos x integration is sin x. Just from pi by 4 to 5 pi by 4. You can simplify the value, you will get the value, that is no problem. So this is the way to find the area of sin x and cos x. Any two consecutive points of intersection. That is one way. Next, I will give one more example by using sin x and cos x graph. Okay? Right. Next, one more graph, that is y is equal to sin x and cos x. Next one, y is equal to sin x, y is equal to cos x and x-axis and x-axis. You see, first you have to draw the graph. 0, pi by 2 and pi. Sin 0, 0, sin pi by 2, 1 and sin pi 0. So this is the graph of sin x. What about the graph of cos x? Cos 0, 1, cos pi by 2, 0, and this will be the graph. So sin x and cos x and x-axis. So this will be the area. This is the area we have to find. This is sin x graph and this one is cos x graph and x-axis. You observe this graph. This is just like a triangle, but the sides are not lines. These are two curves, one is a line. So this is called curvilinear triangle. Curvilinear triangle. The curvilinear triangle of the curve sin x, cos x and x-axis. So this will be the area. How to find the area? The graph sin x and cos x intersect at some point pi by 4. You observe the graph deeply. From 0 to pi by 4, the area occupied by sin x only. This is the area occupied by sin x. So after pi by 4, sin x graph goes like this. And from pi by 4, cos x occupies the area. So the area is 0 to pi by 4 sin x dx plus pi by 4 to pi by 2 cos x dx. This is the way to find the curvilinear triangle area. So this is minus cos x from 0 to pi by 4 plus sin x pi by 4 to pi by 2. So this is minus of 1 by root 2 minus 1 plus 1 minus 1 by root 2. This is 1 plus 1, 2 minus 1 by root 2 minus 1 by root 2 minus 2 by root 2. That is, so the area is 2 minus root 2. This will be the area. From the same diagram we can find one more thing. I will explain. So this is the area of curvilinear triangle between sin x, cos x and x-axis. I will draw the same. You see, from the same diagram, this is also curvilinear triangle. This is the area of sin x, cos x and y-axis and y-axis. If they ask like this area, what about? How to find this area? You see here, this is the area, just we find out the area, that is 2 minus root 2. But we have to find the area of this one. how to find this area. This is the graph of sin x. This is the graph of cos x. Sorry, this is the graph of cos x. Any arc of either sin x or cos x occupies the area of 2 square units. So this entire graph occupies total is 2 square units. This is half of the graph, semi-curve of cos x. So it occupies 1 square unit. So the total area is 1 square unit. This area is 2 minus root 2. So this area will be 1 minus of 2 minus root 2. That is root 2 minus 1. So this is the area of y is equal to sin x, cos x and y axis. Okay. Next. Okay. Next I will explain. Y is equal to cos x and y is equal to 1 minus 2x by pi. Y is equal to cos x and y is equal to 1 minus 2x by pi. How to find the area? These are the two. This is a curve and this one is a straight line. Now first you draw the graph. Cos x graph. This is minus pi by 2, 0, pi by 2. So the graph will be like this. This is 1. How to draw the graph of this one? Whenever this type of lines are given, better you put x is equal to 0. When x is equal to 0, what will be the value of y? It is 1. So 0 comma 1. That is 1 point. 0 comma 1. Pi by 2. What is meant by pi by 2? Pi by 2 means 3.14 by 2, that is around 1.7, 1.6 something, no problem, 1.6. So this is 1.7, so 1 will be here only and here minus 1. So 0 comma 1, x value 0, y value 1 here and put y is equal to 0. Then what happens? If y is equal to 0, 2x by pi is equal to 1. Now x is equal to pi by 2. Now the point is pi by 2 comma 0. Pi by 2 comma 0. So this is the point pi by 2 comma 0. And here is the point 0 comma 1. So this is the point 0 comma 1. This is pi by 2 comma 0. So the line will be like this. So this is the line. And this one is the area we have to find. And the curve so this is also area of the line. Okay. Now if you find this area, this is also same. Now how to find the area of this one? We observe this one. This is the semi area occupied by the cos x. Just I told you this is the area. The area is 1 square unit. 1. This is 1 cos x area. One of the arc occupies 2 square units. This is half of the curve cos x. So it is 1. 1 minus this, subtract this area. This is nothing but triangle. What is the area of the triangle? Half base. Base is pi by 2 and height. Height is equal to 1. So 1 minus pi by 4. This is the area of this one. So this is also same area. 1 minus pi by 4. So total area is equal to 2 of 1 minus pi by 4. So answer is 2 minus pi by 2. Next. Okay. Next, I will give one more example. Y is equal to cos x. Y is equal to cos x and y is equal to x plus 1 and y is equal to 0. Y is equal to 0 means it occupies area with the x axis. First to draw the diagram, cos x. Minus pi by 2, that is minus 1.7 around, minus 1, 0, 1, and this one is pi by 2. Pi by 2 means around 1.7. This is the value 0, comma 1. So this is the graph cos x. How to draw the graph? Y is equal to x plus 1. This is the straight line. Simply we can draw like y is equal to x plus 1. Put x is equal to 0. When x is equal to 0, y is equal to 1. That means 0, comma 1. Put y is equal to 0. If y is equal to 0, x is equal to minus 1. So minus 1, comma 0. This is minus 1, comma 0, and this is 0, comma 1. So the line will be like this. So what we have to find? The area between cos x graph and this one. In between the area. This is cos x graph and this one is the line. So this is the possibility of the area. Okay. Now how to find this area? This is the total graph of one arc of cos x. It occupies 2 square units. From here to here the area is 1 square unit only. So 1 minus area of this triangle, half, base 1, and height is also 1. So the answer is 1 by 2. Next, y is equal to tan x between minus pi by 3 is less than or equal to x less than or equal to pi by 3, and y is equal to cot x pi by 6 is less than or equal to x less than or equal to 3 pi by 2. So first to draw the graph of tan x. So you know the graph of tan x. This will be the graph of tan x. At pi by 2 it will be infinite. At minus pi by 2 it will be minus infinite. What about the graph of cot x? It is 0. At 0 it is, and this will be pi at pi. So this is graph of cot x and this one is the graph of tan x. Both the curves intersect. Tan x and cot x intersect in between 0 to pi by 2. This value is pi by 4. So we have to find this area and this area. This is the required area. We observe the graph. From 0 to pi by 4 it occupies the area occupied by tan x only. So 0 to pi by 4 the area occupied by tan x it makes. From pi by 4 to pi by 2 the area occupied by cot x graph. So pi by 4 to pi by 2 area occupied by cot x. So integral tan x, what is the formula integral tan x? Log mod secant x between the limits 0 to pi by 4 plus log mod sin x between the limits pi by 4 to pi by 2. So you can find the value, no problem. Log of secant pi by 4 is root 2, log of root 2 minus secant 0 is 1, log 1 is 0 plus log of sin pi by 2 is 1, log 1 0 minus log of sin pi by 4 that is 1 by root 2. This is 1 by 2 log 2 minus 2 to the power of minus 1 by 2. Minus minus plus 1 by 2 log 2. Now the answer is log 2. So this is the area in between y is equal to tan x and y is equal to cot x. Okay, next one more question. This is also one of the important questions that was given in the previous IIT examinations. That is y is equal to tan x, y is equal to tan x, and the tangent at x is equal to pi by 4 and with x axis. Here the graph is very important. when x is equal to pi by 4, what about y? Y is equal to tan pi by 4, that is equal to 1. Now the point is pi by 4 comma 1. Then we have to find the tangent, equation of tangent. Y is equal to tan x. What is its derivative? Dy by dx is equal to tan x derivative secant square x. At the point pi by 4 comma 1, that is secant square pi by 4, that is equal to 2. So this is nothing but slope. So we have the point and the slope. Therefore, equation of tangent is y minus y1 is equal to slope into x minus pi by 4. Okay, this is the tangent and this one is the curve. So you observe the graph. What is the graph of tan x? This is pi by 2 and this one is minus pi by 2. This is the graph of tan x graph. What about the tangent? Tangent drawn at pi by 4 comma 1. This is the point pi by 4. So this will be the point pi by 4 comma 1. And here the tangent is drawn to this tan x graph. This will be the graph of tangent. This is the tangent at pi by 4 comma 1. So we have to find the area of this one. This is the area. How to find this area? This is the graph of tan x and this is the tangent. This is the tangent. In between the curve tan x and the tangent, we have to find the area. You observe this one. This is the point pi by 4. From here to here, this is the area occupied by tan x. 0 to pi by 4 tan x. From here to here, 0 to pi by 4, this is the total area. But we require only this area. So we have to subtract this area. 0 to pi by 4 tan x dx minus area of triangle. This area of triangle. How to find the area of triangle? First you have to find this point. This is the equation of tangent. When x is equal to 0, then what about y is equal to 0? When y is equal to 0, that is minus 1 is equal to 2 of x minus 4. Minus 1 by 2 is equal to x minus pi by 4. So x is equal to pi by 4 minus 1 by 2. So the point is pi by 4 minus 1 by 2 comma 0. So this point is pi by 4 minus 1 by 2 comma 0. Pi by 4 minus 1 by 2 comma 0. This is the point. So first we have to find the area of this triangle. Again, this is log mod secant x between the limits 0 to pi by 4 minus area of the triangle half base. Base means this one. Height is just, we know that this is 1. From here to here this is pi by 4, but we have to find this one. This is nothing but pi by 4 minus of pi by 4 minus 1 by 2. This total distance is pi by 4 and this distance is pi by 4 minus 1 by 2 into height means 1. That is equal to secant pi by 4 means root 2. Log of root 2. Secant 0 is 1, log 1 is 0 minus half into pi by 4 minus pi by 4 cancel, it is 1 by 4. That is 1 by 2 log 2 minus 1 by 4. So this is the way to find the area of tan x and its tangent at x is equal to pi by 4. So we will continue in the next class. Thank you.